There is a common saying in academic and professional studies: a problem clearly stated is a problem half solved. If you do not know exactly what you are looking for, you have no chance of finding it. The framework laid out in C.R. Kothari's research methodology sets a strict baseline. If you are doing exploratory research, your goal is actually to find and develop a hypothesis. But for descriptive or hypothesis testing research, precisely defining the problem is a mandatory first step. This chart represents how projects start: a broad, unstructured area of interest with thousands of overlapping variables. The danger is proceeding to data collection from here. If you do not draw sharp limits, you will drown in irrelevant information, wasting valuable resources. Formulating a problem is rarely a sudden moment of inspiration. It is a sequential pattern of narrowing down your scope. We can think of this sequential pattern as a mechanical research funnel. We start by dropping that broad, shapeless topic into the top, and we pass it through two primary filters to shave away the ambiguity. The first filter is the literature survey. At this stage, you are not reading to find the answer to your problem. You are reviewing existing studies to find inconsistencies, poorly defined variables, and gaps in current theories. This survey also forces you to confront data availability. If the historical records or field data you need simply do not exist, you must immediately abandon that angle and tighten your focus to match the data you can actually acquire. The second filter is the experience survey. This means getting out of the library and talking to practitioners, subject matter experts, and people currently dealing with the issue. These experts will point out variables you missed and test the real-world viability of your idea. Their input stops you from spending 6 months designing a study that is practically impossible to execute in the field. Let's test this. Pause the video. Imagine your broad starting topic is: why is productivity in Japan so much higher than in India? Write down 3 specific constraints you would add to that sentence to make it testable. Passing your idea through literature and experience surveys establishes the absolute boundaries of your study. You now know exactly what environment you are testing and what data you must collect. Let's look at how the prompt we just practiced evolves. On the left side of this graphic, we have the initial conversational question: why is productivity in Japan so much higher than in India? As a research problem, this fails. What specific type of productivity are we measuring? Are we comparing the entire economies of both nations? What exact time period are we looking at? Now look at the operationalized version on the right. To what extent did labor productivity in 1971 to 1980 in Japan exceed that of India in respect of 15 selected manufacturing industries? Notice the first boundary. The vague concept of productivity is replaced by a highly specific, quantifiable metric: labor productivity. The second boundary secures the timeline. By restricting the study to the decade of 1971 to 1980, the researcher ensures they are only looking at a period where reliable, comparable data is actually available for both nations. Finally, the scope boundary. Comparing 2 entire countries is practically impossible. The researcher narrowed the environment to 15 specific manufacturing industries. This hyper-specific framing removes all guesswork. By resolving the ambiguities through this step-by-step process, you generate a clear working hypothesis, and you know exactly how to build the design for your research.